In Lesson 3, we will talk about metric prefixes. The learning goal is to develop an understanding of the relationship among metric units. For this lesson, you will need your math notebook, a pencil, chart paper, and maybe some markers. If you haven't already done so, go to the Edpuzzle assignment and watch this video on the history of the metric system. So without further ado, we'll start talking about these prefixes. Metric prefixes help us understand and compare different sizes of measurements easily. Each prefix stands for a specific number, showing how much bigger or smaller a unit is. For example, kilo means 1,000 times bigger, while milli means 1,000 times smaller. The chart shows these prefixes in order from kilo on the left to milli on the right. Each step to the left means you're multiplying by 10, and each step to the right means you're dividing by 10. This makes it simple to switch between different measurements, whether it's length, mass, or capacity. If we're measuring a very large capacity of water, we would use kiloliters. For example, 1 kiloliter is equal to 1,000 liters. A fire truck holds 5 kiloliters of water. If we're measuring mass, then we would use kilograms. 1 kilogram is equal to 1,000 grams. An elephant can weigh up to 5,000 kilograms. Some prefixes, like hecto, are less common. So 1 hectogram would be 1,000 grams. One place where you might see this is in food sales in Europe, especially in Italy, France, and other European countries, where hectograms are used at butcher shops. For example, someone might say, "I'll take 3 hectograms of salami." This means 300 grams. Cheese counters might use them, and markets might use them as well. When measuring capacity, you might see the prefix hectoliter, which is 100 liters, in situations like breweries producing beer, in agriculture, where they produce milk, large quantities of milk or liquid fertilizer, or liquid storage. Next, we'll talk about the prefix deca, which has Greek origins and means 10. Again, this is a less common prefix, but you can still see it in places like the food and beverage industry, in situations, again, like beer production or wine production. You'll also see this in Scandinavian countries with respect to water usage, public utilities, and recycling liquid waste. You might see decagrams in Central European butchers and grocers when they're used to talk about sliced meats, cheese, coffee beans, candy, and bulk food. After deca, we just have the base, which are meter, gram, and liter. Now we're getting into the smaller measurements, which all come from Latin origins. So deci is a tenth. Though it's not super common in every day, you might see decimeters in science and engineering where they need precision. Similarly, you might see it in medical imaging and anatomy. Next, we have centi, which means 100th. 1 pencil measures approximately 19 centimeters. Finally, we have a super common prefix, which is milli, and you'll see this in length, mass, and capacity in millimeters, milliliters, and milligrams. For example, the very tip of a sharp pencil measures 1 millimeter. Next, we'll discuss a mnemonic device that will help us remember the metric prefixes. A mnemonic device is a device such as a pattern of letters, ideas, or associations that assists in remembering something. To remember the metric prefixes, try to memorize this silly sentence. King Henry died by drinking chocolate milk. The K in king stands for kilo, the H in Henry stands for hecto, the D in died stands for deca, the B in by stands for base, the D in drinking stands for deci, the C in chocolate stands for centi, and the M in milk stands for milli. Another way to remember words or prefixes is to think about their etymological origin. As previously mentioned, the larger prefixes are of Greek origin. So kilio stands for 1,000, hecaton 100, deca 10. And then the smaller prefixes are Latin. So deci stands for decimus, tenth. Centi comes from centum, 100, and milli comes from mil, 1,000. Now that we've learned the different metric prefixes, let's learn how to convert metric units. If you're moving to the right, you will multiply by 10 for each step. For example, if you are moving from kilograms to grams, you are moving to the right. Therefore, you will multiply by 10 for each step. In this case, you will multiply by 10 3 times, which also translates to multiplying by 1,000. If you are moving to the left, you will divide by 10 for each step. For example, if you are converting milliliters to liters, you will be moving to the left and you will divide by 10 for each step. In this case, you will divide by 10 3 times, which is the same thing as dividing by 1,000. Now take a minute and try to order these measures from least to greatest. If you're super confused, just write something random in the box and move on. The first step is to convert all the measures so that they are the same unit. So I sorted them into the chart to see where they lie in relation to the base. I'm going to convert all of these measures to meters. I'm starting by converting 0.2 kilometers to meters. In order to do this, I multiply by 1,000. If you want, you can use a calculator or you can use mental math. So in order to multiply by 1,000, I'm going to move that decimal point 3 spaces to the right. Therefore, 0.2 times 1,000 equals 200. To keep track of my converted units, I write them above their original unit. Next, I'm going to convert 23 decimeters to meters. Because I'm moving to the left and I'm only moving one step, I'm going to divide by 10. I simply move the decimal point one space to the left. Therefore, 23 decimeters is equal to 2.3 meters. Next, I'm going to convert 390 centimeters to meters. Because centimeters are 2 steps away from meters, I'm going to divide by 100. I know that I'm dividing because I'm going from left to right. 390 divided by 100 is 3.9. Therefore, 390 centimeters is equal to 3.9 meters. Finally, I'm going to convert 450 milliliters to meters. I'm moving to the left, so I'm going to divide, and I am moving 3 steps, so I'm going to divide by 1,000. In order to divide by 1,000, I simply move the decimal 3 spaces to the left. Now I can order these measures from least to greatest. Finally, I want you to tell me which attribute is being measured. Now for each set of measures, I want you to order them from least to greatest, draw each value on a number line on chart paper, and tell me which attribute is being measured. If you've done your unit conversions correctly, you should have gotten this order from least to greatest. This is the correct answer. Again, convert the units to order these measures from least to greatest. Again, draw each value on a number line and tell me which attribute is being measured. If your unit conversions are correct, you should have this order of least to greatest. Okay, we're going to solve a problem. So, Jeremiah is at the grocery store to buy milk. Which is the better deal? Without solving the problem, which do you think is the better deal? And why do you think so? We'll call the small carton of milk option A and the large carton of milk option B. Now let's solve this problem together. The first step is to make sure that our units match. So let's convert 2 liters to milliliters. Because we're moving from a larger unit, liters, to a smaller unit, milliliters, we're moving to the right. When we move to the right, we multiply. We multiply by 10 for each step that we take. Therefore, we will be multiplying 2 by 1,000. 2 liters is equal to 2,000 milliliters. Step 2. Find the unit price, cost per milliliter. For option A, we're going to divide $1.25 by 250 milliliters. What we end up with is $0.005 per milliliter. For option B, we're going to divide 750 by 2,000 milliliters. The cost is $0.00375 per milliliter. Step 3 is to compare the unit prices. Option B costs less per milliliter, therefore option B is the better deal. The fourth and final step is to write your conclusion in a complete sentence. Jeremiah should buy the 2-liter bottle for $7.50 because it costs less per milliliter.